Alright, so now we're going to take a look at what happens when builders inherit from other builders. And the answer is that nothing particularly scary happens, but if your builders use the Fluent interface approach, then you're in real trouble. And there is no easy way to mitigate the inheritance of Fluent interfaces, but we're going to do it anyway. We're going to do it using recursive generics. It's a fairly well-known approach to getting Fluent interfaces to actually inherit. So let's take a look at the problem. So the problem is as follows. Let's suppose we have a class called person where we have, for example, the person's name that we're going to build up, as well as some employment information, maybe the position of the person working at a company. So I'm going to generate the toString implementation so we can print the person, and then let's imagine that we have two builders. So the first builder is the one that just builds up the personal info. So I'm going to call this one person info builder. And this one is just going to build up the name. Now, I'll also have the person itself. So we'll have protected person. That's the object that we're actually building up. Notice it's protected and not private. And the reason for that is we're using inheritance. All right. So what we're going to do is we're going to have a Fluent method, which is going to allow us to specify the name. So it's going to be public person info builder, and I will call this method called, which takes a name and assigns the name to the person. So we say person.name equals name, and then we return this. Now this is a classic Fluent builder approach, and there is absolutely no problem with the code that we've got so far, so long as we don't start inheriting from it. And that's exactly what we're going to be doing, unfortunately. So we're going to imagine the situation that later on you have another business requirement. You have to have a builder which has all of this functionality here, but also additional functionality. And let's imagine that you decide to follow the open-close principle and not actually modify the existing builder. You decide to use inheritance instead. So you make a new class called, for example, person job builder. And this class you decide to inherit from person info builder, which seems like a good idea because, I mean, you do inheritance and you automatically get all of the functionality of person info builder inside person job builder. So it seems like a pretty good deal. So what you do is you add an additional piece of Fluent API. You have public person job builder works as a, and specify the position. So here we specify the person's position. We say person dot position equals position. We return this, and this feels like something that we can actually start using. So you might want to try this one out. So we're going to new a person job builder like so. Make a variable, call it builder. Okay, and then we're going to try initializing the person. So I'm going to say builder dot called. So I can specify the person's name, that's my name, and then I want to specify works as a, but I can't. Why can't I do this? What is the problem? I mean, I thought I was making a Fluent interface here with inheritance. Why is it not working? The reason it's not working is because when you call the called method, you return a person info builder. And person info builder doesn't know anything about works as a because it's not part of its inheritance hierarchy. Person info builder just gives you an interface to the person info builder. So clearly the problem with the inheritance of Fluent interfaces is you're not allowed to use the containing type as the return type. It makes no sense because if you were to do this, then eventually, as soon as somebody calls this method, you're degrading your builder from a person job builder to a person info builder. That's just not good. That's just not a good thing. That's not something that you want to do. So what we need to do is we need to replace this, and we need to replace this thing here with something more sophisticated, something more advanced. Now, one question you might ask is how can a derived class propagate the information about the return type to its own base class? And how can we actually do this recursively? How can we do this infinitely? Imagine you have 5 inheritors, one inheriting from another. How can we do this? And the answer is recursive generics. So let's implement recursive generics on a Fluent builder. Now, the first thing I'm going to do is I'll make an abstract class. Let's go with person builder because I want to take all the common information and I want to put it into this abstract class. So I'm going to stick the actual constructed object here, and I will also have some public method which returns a person called build like so, which just returns the person. So we're going to have this nice kind of API to work with. Now here is the problem. We have the problem that we need some sort of return type here, but this return type has to refer not to the current object, this, but the kind of this that you get through inheritance. So it could be a person job builder, for example. So what do? Well, you stick it as a generic argument, and I'm going to call it self because it's a self-referential relationship effectively. So here we're going to return self. Okay, now the problem with this approach, of course, is somebody could go ahead and stick an integer in here, or a list of integers or something else entirely, and in this case casting this to that object wouldn't make sense. So what we would need to first of all do is put some sort of restriction, and by the way, this has to inherit from person builder, obviously, otherwise you just cannot build up the person because it's not there. But we need to restrict self because otherwise somebody is going to stick something inappropriate in here. We want to restrict self to the inheritors of person info builder of self. So we're going to say self where self inherits from person info builder of self. Now you might say, well, hold on, this makes absolutely no sense. You have an argument and you're expecting that argument to inherit from the current object. How can this possibly be? I mean, you can see that this is still highlighted in red here. So how can this possibly be? Well, the only one situation that we're allowing is we're allowing a situation where self actually refers to the object inheriting from this object. So what you're going to have is you're going to have a situation with lots of classes, for example, foo, which inherits from bar of foo. So in this case, the self argument, the self-generic argument, actually refers to the class that's actually doing the inheritance. So if you have foo, then you need to specify foo as the argument to self, and that's precisely why we have this constraint where self inherits from person info builder. So your derived class is going to derive from person info builder, so by definition it's going to derive from person info builder of self, and as a consequence of this you're going to be able to actually cast this, even though once again both the compiler as well as reshopper or writer in this case, they disagree. I'm just going to cast this manually. I know that this will work in all of the cases, so let's get rid of this. Now we have a second builder, and once again we can no longer just inherit from a person info builder. It has to be a person info builder of a person job builder, like so. But it gets even more interesting because at some point in time you might want to start inheriting from person job builder as well. And if you have it in this kind of scenario, you're not going to be able to do this, because in this scenario what you're going to have is you're going to have person job builder here, and we have agreed that this is a bad idea. We've agreed that we're not going to do this like ever. So once again, we're doing the same thing that we're doing in the person info builder class. We're specifying a generic argument called self, and we're putting a constraint on it. So we're going to say where self inherits from a person job builder. Okay. So this part is particularly easy, provided I get the spelling right. But now this thing gets modified, because it's not just a person job builder in here. It's a person job builder of self. So you can see that as you go ahead and you inherit builders from other builders, this derived line is just going to get really long. It's going to be a big list of types, or what's called a type list in languages such as C++, a fairly common occurrence, by the way. And once again, we return self from this method, and once again, we cast this to self. So that's pretty much it. What we've now done is we've made every single one of the builders, so this builder and this builder, we made these builders amenable to inheritance. So now they support inheritance, and they're going to support the idea of a Fluent interface that actually gets inherited and that returns the right thing. So now what remains for us to do is to actually try this all out. And I'm going to try it out by going into the person class and adding an API, which actually allows us to initialize a new person. Now, remember, you cannot go ahead and initialize a person job builder. You cannot just say something like new person job builder, because it is entirely unclear what you would stick in here. What would you stick in here? This has to be something that inherits from person job builder. And I mean, if you stick program in here, program doesn't inherit from person job builder. So that makes absolutely no sense. As a result, what you do is you make additional types. So for example, if a person wants to expose its own builder, we would make a class here. We would make a class called just builder, for example. I could make a class builder, and I could say this is going to inherit from person job builder of builder. So notice once again the recursive generic approach. So we are passing the type as a generic argument to the base class. And then what we can do is we can expose this builder. So for example, I can have a public property, public static builder new. So I have a property called new, and every time you get a new, you try to construct a new person, it gives you a new builder. There we go. That's all that we're going to do here. Now you can try to make sure that the builder isn't accessible from the outside, but it's very difficult to control effectively. So you can make the builder internal, you can give it an internal constructor, but you cannot go ahead and make it private because it's obviously being exposed through the API. So you cannot just say private builder like so. That's not going to work, unfortunately. So let's just leave it as is for now, and let's take a look at how this is all actually used. So now what I'm going to do, if I want to construct a person using a Fluent inherited builder API, I'm going to say person.new. So that gets me a new builder, and I can say that this person is called Dimitri like so, and then I'm going to do a dot here, and I can say works as a, and I can specify quant, for example, and I can actually build the object and turn it into a person. So I'm gonna say me, and that's actually let's print out me just to see that it works. So I'm gonna run the application, we're gonna see it working, and then I'm just going to go through this once again because it's not a particularly intuitive thing to do. So here's the output, name Dimitri, position quant, so we're getting the right results here. Now let's once again think about what's happening here. So previously, what happened when we used the called method is the called method actually returned a person info builder. But now it's no longer doing that. It's no longer returning a person info builder. And in actual fact, what's happening here is if I just get rid of it like this, and I make a variable here, let's make a variable, person job builder. If we specify explicitly what the type of that variable is, you can see that it's a person job builder of a person builder. So it's the right thing. It's a person job builder, even though it might look as though inside the person info builder, you would be returning a person info builder. That's absolutely not the case. Because we're propagating the information throughout the entire inheritance chain, we are actually always getting the most derived kind of type, and as a result the entire chain of Fluent interfaces is always available to us, which is what we wanted in the first place. So the takeaway from this example is that inheriting Fluent interfaces is difficult and it requires you to make generic classes, but if you do, then it becomes more or less okay, shall we say.